do the standard normal distribution. Basically, we're going to learn how to use a standard normal distribution chart and look up actual z-scores on that chart. So the reason that where we're going with this is that we're going to end up doing an application problem in a couple lessons, and with that application problem, we're going to calculate a z-score, which we've calculated z-scores before. We're going to take that z-score and we're going to calculate it, and then we're going to look up an area on the curve to get an answer for a probability. So this is like one of the steps of a multi-step problem where we're going with this. So I'm going to give you a z-score, and if you remember from a previous lesson, a z-score is just how many standard deviations you are from the mean. So where we're going with this was our formula. So we have our value minus the mean and then over the standard deviation, right? Okay, so sorry. Okay, so your value minus the mean over the standard deviation. All right, so that's your z-score formula. I know that's a little messy, sorry. So what we're going to do is we're going to end up calculating a z-score for somebody, like their height. So for example, I am terribly short and I am 62 inches, and for females the mean is 64.5 and the standard deviation is 2.5. We're going to calculate a z-score for me. Here's where the mean is at 64.5. I am 62, and we're going to find what percentile I'm in. How low of a percent, what percent of the people are actually shorter than me? Not too many, I think it's around 16%. Now, in a previous lesson, we did something called the empirical rule, where we took and said, okay, we have the normal curve, and we have this at 0. 0 is the mean, and we're 1 up to 3, down to 3, 68, 95, 99.7. So that's empirical rule. Those percentages are estimates. What we're about to do now is I'm going to give you a z-score chart, and on that z-score chart, you're going to find exact percentages. So the empirical rule is great, but we use it a lot for just estimating when we don't necessarily have the z-score chart, or we would just need an estimate. We're actually going to go through and use the z-score chart now to find exact percentages. So let me clean this up a little bit. Okay, so let's take a look at this z-score chart. This z-score chart has two sides, and actually this chart comes from AP Statistics, and it's really two pages. This is the front and this is the back. But then what happens is you spend so much time flipping back and forth, I have just decreased it into a front only page. So if we take a look at it, any number z that we look here, this is going to be the whole number and the tenths. So this would be 1.1, and then if I slid over, this is 1.13. That would be that z. So 1.1, this is the whole number and the tenths. And then when you slide over here, that is the hundredths place. So that is that z. We're looking over here on the negative side. This would be negative 2.2, and if we slide over, that would be 6. So that z-score is negative 2.2 down to the hundredths, down to the tenths, excuse me, and over to the 106th. What these are areas underneath this curve. So on the positive side, this area, 8708, represents this area here at a z of 1.13. This area over here, 019, represents this area right here at negative 2.26. So when you look up on the chart a z-score, the area that you're getting inside of here, these are areas or percentages, are always to the left of it. Those are the areas that are to the left. So if I want an area to the right, I'm going to have to do 1 minus it to get it. So if this area is 80, this area is 20, and I'm going to look up an area of 20. With z-scores, I made a mess of everything there. With z-scores, clear some of that up. with z-scores. From now on, I want you to round any z-score to the hundredths place. Why? Because that's how the chart is set up. So if I want a z-score of negative 3.14, that is why I want it rounded to the hundredths place from now on. Okay, and then when we're looking up areas, let's say I gave you this area of 0.3, you're going to change it to 3,000 so that you can then come down here and match it up to one of these numbers. On this side of the curve, because you're on the positive side, all of the areas are going to be over 50%. On this side of the curve, all of the areas are going to be less than 50%. So over here, we start at 50% and increase until we reach 1 or 100%. From here, we start at 50% way down here and decrease until we reach 0 over here. So if you're looking for an area that's over 50, you're going to be on the positive side because your z's are going to be positive over 50%. If you're looking for a z that's less than usually 50%, then you're usually looking for negatives. But we'll talk about that too. There's some exceptions to that. All right, so let me clean that up again before we move on. All righty. Okay, so let's go back to our first problem. And in each of these problems, I would like for you to just sketch your curve. It doesn't have to be pretty. If you printed this out, that's fine, but I would like you to at least just sketch it. So I have the numbers down here. This is my 0, right? 1, 2, 3. You do not need to write the numbers in, but this is just an estimate just to kind of make it nice. Okay, so that's what these tick marks are, is just approximately where the standard deviations are. All right, so first problem. I want to find the area to the left of a z of 1.99. So I go to here and sketch it. Like I said, it doesn't have to be perfect. And the z I want is 1.99. And I'm even going to take these numbers off so I don't even get confused. So I don't even really need them. So I'm just going to say, okay, 0 is z right here, 1, 2. So it's about right here, 1.99. And I want the area to the left of it. So I want this area. So I go to my normal distribution part, and now I'm looking at my z. So I go to 1.9, and then I'm going to slide all the way over to 9. And I get, so 1.9 and then 9. So 1.99, 9767. Go back to my notes, and I get 9767. And basically, that's what I wanted. I wanted the area to the left of it. When I look this up here, that represents that area. That is the same area that I was looking for. All right, next one. We want the area to the right of negative 1.16. So 0 is here, negative 1 and a little bit, just a sketch. Negative 1.16, oops, 1.16. And I want the area to the right of it. So I'm going to go I want this area. Okay, so I go to my negative 1.16. And when I go to my negative 1.16, I get negative 1.1. And I go to all the way to 6. Negative 1.1. And then the hundredths place was 6. And I get 1230. That is this area right here. Okay, let's go back to our notes. That 1230 was that area. That is not what I want. I want to the right of it. Okay, so this whole curve is always 100% or 1. So we just need to do 1 minus 0.1230 on our calculator, and we get 0.77. It should be 8, I think, right? 10, 10, yes. So 87, 70. And that is the area that I want. All right, make sure you're finding the right area that corresponds to it. Let me repeat that. When I look up a negative 1.16, it gives me this area. But that's that area right here. I want the area to the right of it. Every curve is 100. Just do 1 minus it. Okay, now between twos. All right, so this is kind of super important. So I'm going to put this in red. Between twos. Okay, anytime you're between two, look up areas, and then you're always going to look up the areas straight up. Don't change anything, and then you're going to subtract areas. We never, ever, ever, ever subtract z-scores. Never subtract z-scores. All right, so let's do 0 is here, right? There's my 0. So I want the area between 1.68, 1 to 2. Oh, that's good. 1.68 and negative 1.37. So negative 1.37. Okay, so this is the area that I want in this red. Okay, so I'm going to go to my chart and look up my two z-scores. So the first one was 1.68, 1.6. Slide over to, can you hear the golden retriever snoring? 9535. So 1.68, 9535. I'm going to write that first one down. Okay, and then what was my other z? Oops, 1.37. Negative 1.3. And I go all the way over to 7 right here. So 1.3 slide to 70853.0853. Okay, so let's talk about that. 9535 is all of this. All the way, all of that. Okay. 0853 is this. Okay, so if we take that purple away, right now we have all this green. If we subtract out that purple and cut that out, we'll have what we want, which is the two numbers in between. So you're going to look up one, look up the other, and you're always going to subtract the smaller area out. You're taking this piece out. If you take this 0853 out, then all you have left of the green is this red area that we want. So 9535 minus 0853, and we get 2, 8, and then that would be 14, 6, 6682. Let me make sure I'm doing that right. Sorry. Oh. Okay. I didn't do something right. 8, oh, that's 8. It's 8. I knew I didn't do something wrong. Sorry, I was looking at the next problem. 8682. Sorry about that. 8682. So there we go. I can't subtract. Did I do everything else right? Yeah. Okay, and that's right. Okay, questions on that? All right, so between twos, look up your areas and subtract your areas. Never, ever subtract z-scores for any reason, ever. Should you ever subtract two z-scores? Those are locations on the curve, and we never subtract those. All right, let's do another one. Between 2 and, so 1, 2, and 2.47. This is going to be a super small area right here. So 2 and 2.47. It doesn't matter. It's a between two. Between twos, we subtract. So we're going to go to our chart. I'm going to clear up my selections. We're going to look up two and 2.47. So just 2.00, 2.00, 9772, and then 2.47. Slide all the way over to 7. Keep going. Over to here. There's 2.4 and then 7. So always whole number tenths, slide over to the hundredths. Okay, and we get 2.47's area is 9932, and area for 2.0 is 9772. And we always subtract their areas. So what we just did, this 2.47 is all of this. We only want between these two numbers right here. That's all we want. So right now we have all this yellow. And then if we take and subtract out 9772, we take all this away, then we're left with just this area we want. So if you subtract 9932 minus 9772, you will get 0160. So it is that area right here, this area right there is 1.6%. These are actually percents once you move them over. Like this one is 86.82% once you move the decimal over. Okay. All righty. Almost done. Now we're going to find an area between 0 and a z. Okay, so 0 is here, and the z is 1, 2, about 2.34. Right, still a between two, but between these two. All right, so I'm going to look up 2.34. 2.3, and then slide over to 4. 9904. So 9904, and that's all of this, this, plus this, all of this. Okay, now I'm going to look up zero if you want. You don't have to. 0 is 50-50. So all of this that I want to take out of there is 50%. 0 is the z right at the mean. You haven't moved any. So your z is 0 because you haven't moved any. So 0 is here. This is 50%. And then I'm going to take this whole, all this green, and subtract out half of it. And I'm going to get my answer, 9904 minus 0.5000, 4094. So my answer is 49.04%. So that's looking up the z's and getting areas. So that's it for the notes.